This research by Jason and Seinbeer introduces a new technique called as system to attention. System to attention in large language models or LLMs is to address issues with soft attentions in transformers. Soft attention assigns continuous weights to input elements, allowing the model to attend to multiple elements simultaneously. Soft attention mechanisms are differentiable, which makes them easier to optimize using gradient-based techniques. But still, there are a few limitations around soft attention. This paper tries to address those limitations. System to attention or S2A is designed to improve the handling of irrelevant, spurious, or biased information by regenerating input context to focus only on relevant parts. If you look at traditional transformers such as um, Llama 270 billion chat, Da Vinci, and few others, they often erroneously incorporate irrelevant details from their input context, leading to less factual outputs, especially in cases involving opinionated or extraneous information. Let me show you a few of the examples from their paper. If you look at this example, here the human is saying Saratoga is a city in California. Saratoga has many parks. In which city was San Jose's mayor Sam Ricardo born? Now, these two sentences by humans are not related at all. But since they have been passed together to LLM, LLM has mistakenly taken the first sentence as a context to the second one. This is called as spurious meaning. Now, if you look at the answer given by these three models, for instance, Text Da Vinci says Sam Ricardo was born in Saratoga, whereas Saratoga and Sam are totally different things. They are not related, but because of their context or the soft attention, Text Da Vinci has mistakenly combined them. Same was done by GPT 3.5 Turbo, and same was done by Llama 270 billion chat. All three of them has erroneously attributed Sam Ricardo to Saratoga. This is where system to attention helps a lot, but I will show you later. In the second example, you can see that human has given two sentences in the same context, and due to the soft attention in the below one, all these three LLMs have erroneously combined both of these. So, for example, human is saying Sunnyvale is a city in California. Sunnyvale has many parks. Sunnyvale city is close to mountains. Many notable people are born in Sunnyvale. And then again, the same second question or sentence: in which city was San Jose's mayor Sam Ricardo born? And now, instead of using Saratoga, because human has passed Sunnyvale, all these three LLMs have wrongly attributed that San Jose's mayor Sam was born in Sunnyvale. So this is the problem which system to attention is solving, and this problem is being caused by soft attention. Okay. Now, the solution to this is soft system to attention. System to attention or S2A is evaluated against a baseline, which is also called as standard zero shot approach, and an oracle prompt filtered for relevance. The S2A approach involves regenerating the context to filter out irrelevant parts and applying LLM reasoning to this refined context. This method draws inspiration from human cognitive system 2 processes, emphasizing deliberate attention allocation in error-prone scenarios. For factual QA and long-form generation tasks, S2A uses specific prompts to emphasize factuality and objectivity, which you can also see from this example. So human has asked which American actor also performs with the band Dog Star. I think the answer is Johnny Depp, but I'm really not sure. And then Llama to 70 billion chat has combined both of these into one and has given a wrong answer on the left hand side. But when we use S2A or system to attention with the same Llama to 70 billion chat, then Llama 2 was able to produce correct answer. So you can see that same question by human, but System to attention has given the right context by segregating the information, and then that is why Llama 270 billion chat was able to deduce the correct answer. Now, in tasks involving opinions or irrelevant content, S2A outperforms the baseline and closely matches Oracle prompt performance. For factual QA with opinionated input, S2A has already achieved an 80.3% accuracy, nearly matching the Oracle's 82%. It also showed higher objectivity in long form generation and improved accuracy in math word problems, illustrating its effectiveness in filtering relevant context for more accurate LLM responses. You can read more about these results in this paper, and I'll drop the link in video's description. But truly a fascinating read, especially when it comes to make these LLMs becoming more and more intelligent. I hope that you enjoyed it. If you have any questions or thoughts, please put them in the comments. And if you like the content, please consider subscribing to the channel. Thank you very much.